So at the top of our note sheet today, you'll see that there's a review of all the properties of exponents. This was what we reviewed on 7.A, which was like before we started 7.1. I reviewed all the properties of exponents with us. And we practiced those with just regular integer exponents, positive and negatives. These rules all still apply for rational exponents. So if you are multiplying something that has the same base, you can add the exponents. So 1/3 and 2/3, add this together, we get 3/3, which is 1, and then that's 8 to the first. The power rule still works. Power to a power, we multiply those. So if you have 5 to the 1/2 to the 4th power, you can multiply those, which would be 4/2, which is 2. And it also works too with, if you have this exponent outside, you can distribute it to each of the terms inside. Negative exponents still do the same thing. And if we are dividing, remember, we subtract. So we're going to take that concept and we're going to add it to with rational expressions. Now, all the ones on the front should be pretty easy because they're numbers. Now, if you're doing these with a calculator, you can literally just type into your calculator what you see with a caret symbol. You would want to use parentheses. We are going to do this by hand, but I want to make sure I do show you how to do it in the calculator too, in case you wanted to check your answers. But so you would type it in pretty much as you see it. Negative 27 caret. Now you do need to put parentheses around the 2/3. 2 divided by 3. We'll get 9. Okay. So in the calculator, just be aware. I prefer you to do these by hand for practice, but if you wanted to check it in your calculator to make sure you did it right, I want you to know how to put it in properly. Now when we're doing them by hand, what we would do is take the root. Remember, the index is going to be the denominator, so this would be the cube root of negative 27. Now normally we put the squared inside, right? But personally, I don't know what 27 squared is off the top of my head. I only know up to my 625. So what I suggest you might want to do is actually put the squared outside. Why? Because I know what the cube root of negative 27 is in my head, and then I don't have to reach for my calculator. So you can, I'll just put or, you could do the cube root of negative 27 squared, but again, then you're going to have big numbers. So those are the same thing. So the cube root of negative 27 is negative 3. Negative 3 squared is 9. Now the next one has next couple have a negative, so we have to first use our negative exponent rule, which would be 1 over 25 to the positive 3/2 power. And now I'll do 1 over the cube root of 25, the square root, sorry. Denominator is our index. The square root of 25, and again, you have the option to put the cube inside, or you can put the cube outside. And this will be easier, because the square root of 25 is just 5, and then 5 cubed is 125, so 1 over 125. Now if you did that in the calculator, you get a decimal, you just have to press your math fraction button to convert it back if you were checking your work. Now the next one has a decimal. Remember, if you see a decimal, you just need to make this a fraction. So 2.5 would be 2 1/2, negative 2 1/2, which will be 5/2, negative 5/2. Move that to the denominator then. So we'll have 1 over 25 to the positive 5/2 power. And then let's change it back to radical form. So the 2 tells me that's my index, so that would be the square root of 25 to the 5th power. The square root of 25 is 5. And then we probably would need our calculator to evaluate 5 to the 5th. We'll get us a big number, and it is 3,125. You do want to leave them in fraction form because this decimal will be very, very small. You wouldn't want to round it. See if you guys can try the next two before we add in variables. All right, Hannah, what'd you get for 20?
6.
No. I know what you did wrong at the end. Clint? 8. Did you get 2 to the 3rd? Or no, maybe not. We should have had the 5th root of 32, quantity cubed, and then the 5th root of 32 is actually 2. 2 to the 4th is 16, so 2 to the 5th would be 16 times 2, which is 32. So maybe that was your mistake actually was here. And then we have 2 to the 3rd, and I was thinking maybe you did 2 times 3 is 6 instead of 2 times 2 times 2 is 8. Common mistake. And 21, what about Steven? Didn't finish all of it. How about Maddie? 16. So this one was the 5th root of negative 32 to the 4th. The 5th root of negative 32 is negative 2. Remember, an odd root, take the root, it's negative. And then since we're raising that to an even, it will be a positive. Make sure you don't have a negative 16. All right, let's throw in some variables. We'll start out with a couple easy ones, and then you can tell like the font switches. These were book problems. These are like your homework questions, but we're going to do the odds in class. The homework are the evens from that section. So I picked some of the actual book problems just to give you guys some sampling of what they will look like. So they do want us to write this in simplest form, and there are, again, different ways you can choose to attack these. You could choose to distribute this first, everything, or use your negative exponent rule first. Personally, I always use my negative exponent rule as a rule of thumb just to get all the negatives gone. So since that's a negative 1/3, this would be 1 over 8x to the 15th to the positive 1/3 power. And then we can change that back to root form. The index is 3, so this would be the cube root of 8x to the 15th power, technically all to the 1st, but, and then we just cube root everything. So the cube root of 8 is 2. And what do I do with the exponents for my x to the 15th? Caleb? Divide. So 15 divided by 3 will get me x to the 5th. Next one, we do have a negative exponent, and it's up to you whether you want to move that first or you want to take the root. Again, I usually move my negatives just because I like to, but that's a personal preference. So I would probably make that 243 all over 8 to the 10th. And then this is all to the 2/5 power still. So that will be the 5th root of 243 over 8 to the 10th. And then it's up to you whether you want to square each of these things or if you just want to do a big quantity squared. Remember that the denominator is our root, so that's the 5th root, and then the numerator is what we're squaring. And so then we actually have to find out what is the 5th root of 243. You might want to use your calculator to figure it out. 5th root of 243. Remember how to get the roots on our calculator? 5, math. Ashley? Is it? Should be 3. So you should have 5, math, x root button, and what was it? 243. You should be getting just 3. I'm sure you took that in right. Some students, and me actually, I prefer, if I have to do this, instead of having to press 5 in math, I would just raise this to the 1/5 power. I think it's faster than going to the math feature. If you prefer, you can type it in like that. But we will get 3. And then in the denominator, we have to divide those. So 10 divided by 5 will get me a squared. Now remember, this is still quantity squared, so we square the top and we square the bottom. So this will get me 9 over a to the 4th. Now below, we're going to have to do the same thing simplifying, but you're going to notice that we have multiple things being added, subtracted, multiplying, and dividing, and some of them do get a little bit complex with parentheses and brackets and so on. But you're just using your exponent rules. So notice we do have the same base here. These are x's and x's. What can we do with the exponents if we're multiplying terms with a common base? Do I add them, multiply, subtract them? What do I do with the exponents? Since these are the same bases. Garrett? Nope. Multiply would be if it was x to the 2/7 to the 3/14. That's power to a power is when you multiply. Caleb? Add them. So this is the product rule. Let me give you another simple example. If I asked you what x to the 2nd times x to the 3rd is, you would tell me x to the 5th, right? 2 plus 3 is 5. Same thing, but we have fractions. Okay. Now, in order to add fractions, you have to have a common denominator. So you would need to actually make this x to the 4/14 times x to the 3/14 so that you can add the exponents. You can't add them unless they have a common denominator. And then to add fractions, remember we just add the numerators, so that would be 7. The common denominator stays common. Do not make it 28. And then we can reduce that to be x to the 1/2. They didn't tell us if they want our answer in radical or exponential form, so you could either leave it like this or the square root of x. One or the other, it doesn't matter. I'm not sure what the book has as the answer key for these problems. I'll look at it before I let you guys do your homework, but either one's the same thing. Now the next one is a division sign, which normally when we see division, it's actually like this, right? Instead of seeing a division symbol, we see that bar. What's the rule for if we're dividing things that have the same base? What do we do with the exponents? Lexi? Good, we're going to subtract these. In order to subtract, again, we need a common denominator. So I'm going to make this 6/10 instead of 3/5. So 6/10 minus 1/10 would be 5/10. Reduce that, we also get 1/2, or the square root of x. As we move down the page, you can see that they get a little bit harder because we have different fractions and we have negatives going on. Again, you have options. This one, for the x's, you definitely just need to subtract those. So we have 2/3 minus 1/2. We need a common denominator between those, which would be 6. So we'll multiply this one by 2 and this one by 3. Get 4/6 minus 3/6, which will be 1/6. Now for the y's, we have negatives. So it's up to you whether you just want to subtract with the negatives, or some students like to move them. So some students will move the y to the negative 1/2 up here, and y to the negative 1/4 down here, and then subtract. Doesn't matter, whichever you prefer. I usually go straight to subtracting. So this would be negative 1/4 minus a negative, which becomes a positive 1/2. And again, I would change this to be 2/4. So negative 1/4 plus 2/4 is 1/4. And then you can either leave your answer like that, or you could make it the 6th root of x times the 4th root of y. Same answer. Why don't you guys try the next 3, and then we will go over them because they are a little bit tricky. But I'd like you to try them. If you want to move around and work with a partner on them, you can, just to kind of bounce ideas off of one another. Putting this over 24/36. And then we subtract. 11 minus 24 will get me a negative 13/36. And then you should not leave negative exponents at all still, so we should do 1 over x to the 13/36 power. And that was our final answer. Or you could do the 36th root of x to the 13. So that one was the hardest because it really required you to use all of the rules. Product rule, power rule, and quotient rule all in one problem. Okay, the last one has just a lot of power to a power, which is all to multiply. So negative 1/2 times 2 would be negative 1. And then negative 1 times 1/3 is negative 1/3. So you should have 1 over x to the 1/3 power. Or you could have 1 over the cube root of x, if you prefer. Okay. Some of the homework problems will be simpler, but some of them will be harder because they're going to be these problems with the evens. So you want to take your time with it and kind of really think through, what rule do I see? I see power to a power. What do I do with that? I multiply it instead of adding it. Okay. Our test is going to be on